Roger. So, we see a big round of applause.
Take a roll of sellotape into a dark room. Not just a gloomy room, a dark room so dark that your eyes have to adjust to be able to see. You've then got the sellotape, and as you pull it, you will see an eerie blue glow. It's called triboluminescence. We've known about it for hundreds or maybe thousands of years, and yet scientists still don't quite know what's going on. We know that the sticky of sticky tape is caused by van der Waals forces. So it's not the nuclear bonds that's holding the nucleus of a cell together. It's not the covalent bonds of the electrons being shared between atoms. But if you've got molecules that have got a slight negative and a positive end, and you've got two molecules, when they come together, one positive will want to touch the negative of the opposite molecule, just like a north and south on a magnet. And when you break this van der Waals force, this van der Waals bond, you break it, the energy given off is 100 times less than that required to make one photon of light. So the sticky isn't what's causing the light. We know that when we pull the sellotape, it is charged. As you can see, it's coming towards my hand, just the same as when we rub a balloon on our head and stick it to the wall. And it's quite easy, it didn't take much effort to pull that apart and separate the charges. Scientists believe, but aren't quite sure, that when the charges come back together, that is when the energy is released. That big coming back together will produce enough energy to cause the light to glow. But it gets weirder than that. You take the sellotape and you put it in a vacuum where there's no air molecules to get in the way, and you pull it apart again. Not only will you get the light, you'll also get X-rays, stronger than comes from a dentist's X-ray machine. So, if you want to do an experiment where scientists can't really answer, take your sellotape and your Christmas wrapping, go into a really dark room, pull it apart, and see if you can see the light.
I liked your use of the sellotape, but I also liked your clapping. It did strike me at the time that you could perhaps have pointed out that when you're clapping your hands together, that you get a noise because of what's happening with the energy. Yes, yes. Which might have given us an analogy to make with what's happening with the forces in the sellotape. I think I'm still slightly in the dark. I mean, obviously what you're saying is that we don't understand this question, but I thought I understood you to say that what gave off the light was the forces coming back together again. Probably. But you described the light coming off as you did that, rather than as you put the sellotape back together again.
Yes, so it's not the separation of the charges that actually produces the light, but once you've pulled them slightly apart, they will get back as soon as possible.
But if you're holding them out,
well, the light that you'll see is actually just at that axis.
Right.
And then, so as you're pulling down, it will just be up there.
Right, okay. I'm going to go home and try this. Sounds really fun.
You need to darken out your eyes.
Right.
And it also works with sugar cubes. If you squash sugar cubes.
Okay, good. Right. Thank you, Lisa.
Hugh.
Thank you very much. Very good, confident style. I really liked the way you presented and spoke. In fact, I think it was very much kind of a story that you were kind of taking us on this journey. And so I kind of would like to hear kind of a bedtime story written. It's slightly oddly, yeah, but okay, we'll move on. Sorry about that. I have seen that exact experiment done, and I did see a report a long time ago where their researchers had just put a spool of sellotape and unwound it, and then put some photographic paper and a finger in between, and you could expose the photographic paper to see the bones. So one question I had at the back end of that particular paper was, how dangerous is sellotape, and should I be using it to wrap my presents?
Okay, so the air molecules will actually block. The air molecules, unless you've got your finger right up underneath there, the air molecules are going to block any X-rays. You're not going to get enough energy to produce X-rays unless you're in a vacuum. So don't go doing this in space. But in normal life, you'll see the glow, but it won't harm you.
Thank you very much.
Okay.
Yes, that was great. I do love a talk about things we can't explain, because I'm a neuroscientist, I do them all the time. And I'm struck by the irony that I sometimes give talks on chemistry and physics, so that I've got something I can explain. In a general sense, what do you think the balance should be when talking to the informed general public about science? Is it a good thing to be completely upfront about what we don't know? Is that why you picked this subject?
A lot of people will think that science I believe a lot of people believe that science was done a long time ago. We know a lot of the answers, and now we're only trying to work out less day-to-day things like the Big Bang. And so actually to bring an experiment that we can all do at home, and to say, you can do this experiment too, it isn't scary. It isn't, you don't have to have a diamond light source, to do this experiment. You can actually do it yourself. Brings it home that science is every day. And I think that's quite important.
Thank you very much.